Hi everyone, welcome back. This is also another video on the same topic that we started, that is hydrocarbon. So today we are going to continue from where we stopped, but before we start doing everything, I have to introduce myself again. My name is Mwiza Chirwa. We'll be going through hydrocarbons part 2. So what do we expect to achieve by the end of this lesson? So the success criteria that we are going to achieve by the end of this lesson are as follows. So by the end of the lesson, you should be able to describe laboratory preparation of alkanes, and as well as you should be able to describe physical properties of alkanes. So to begin with, laboratory preparation of alkanes. So in the previous lesson, we discussed much on the alkanes. What are the alkanes? We looked at the members of the alkanes. So in this video, we will focus on how can we prepare different members of alkanes. Because if we just say preparation of alkanes is too broad, but we can prepare different members of alkanes. Remember, we said we have many members of alkanes, but for our own specialization, we focused much on 10 members of alkanes, starting from methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So we can prepare each member of alkane using the procedure that we are going to look at in this video. So when we want to prepare an alkane, we need the following materials. We need sodium acetate, that is a salt, as well as soda lime. So we'll be able to know in details what are sodium acetate, or we call it sodium ethanoate, or soda lime. We're going to look into details about it. So the question that can be asked on this section is describe how you can prepare methane. So here we have just used one example, but the same procedures can be used to prepare other members of alkanes. So the aim of our experiment is to prepare methane gas. The aim is to prepare methane gas. Materials that we need, as well as the apparatuses that we need hard glass test tube, we need a trough, we need source of heat, we need soda lime. So when we talk about soda lime, what is it all about? It's a mixture of calcium hydroxide and sodium or sodium hydroxide. It can be a mixture of sodium hydroxide or sodium hydroxide. Calcium hydroxide or sodium hydroxide, we call it soda lime. Then we need a delivery tube, we need a gas jar as well. So the procedures, first of all, we need to measure 4 to 5 grams of sodium ethanoate. Remember there we just generalize it to be sodium acetate, but since here we are making or we are preparing methane, we use sodium ethanoate. There's specification in terms of the salt that we are going to use. Later on we are going to look into details of why do we need to specify the salt that we are going to use depending on the alkane that is being formed or prepared. So you measure 4 to 5 grams of sodium ethanoate, and you also measure equal amount of soda lime and put them in the mortar So the first thing is you are going to measure 5 grams of sodium ethanoate and put it in a mortar. Then you are also going to measure another 4 grams or 5 grams of soda lime and put it in a mortar. Then after that, you are going to grind the content using a paste. You are going to grind them using a paste. Then you are going to transfer the mixture into a hard test tube. You're going to transfer the mixture in a hard test tube. So the setup will look like this. Um, somewhere else you have a mortar and pestle. After you grind them, the mixture is going to be transferred in the hard test tube. So this is the hard test tube. After all the preparation have been done in terms of grinding, you are going to transfer them in the test tube. So the setup will look like this. So this is a delivery tube. We have a trough, we have water, then here we have a Bunsen burner here heating our substance. So here you are saying sodium acetate, which in this way we are using sodium ethanoate plus soda lime. The mixture is here, which is heated here. So what happens when it is heated? So heat the test tube with the mixture and observe what is happening. Note, make sure that the water is not sucked back by removing the delivery tube from water immediately after heating is stopped to avoid mixing the mixture, the gas which is going to be produced with water. So when the mixture is heated, what happens? Sodium ethanoate react with the soda lime and form methane gas and sodium carbonate. Now we'll go back to what I was explaining, that why do we have choices in the salt that is going to be used. So when we want to prepare sodium, we want to prepare methane gas. The chemical formula of methane, as you can see from the chemical equation here, is CH4. CH4. But in sodium ethanoate, this is the formula. We have CH3COO-Na. This is sodium ethanoate. So when this one is heated and react with this one, it breaks. As it breaks, it forms methane, which is going to have a single carbon. Then we have sodium carbonate here. So the last part, which is sodium carbonate, which is here, also comprises of carbon. That's why the choice of the salt that is going to be used matters. So for instance, maybe we want to prepare ethane, not methane again. So it means here we are going to use what? We're going to use sodium propanoate, such that the compound which is going to be formed here will have two carbons, which is ethane. So the equation illustrates the process, what is happening. So we have sodium ethanoate reacting with soda lime to produce sodium carbonate and methane gas, as illustrated by the chemical equation which is here. So methane is colorless gas which is collected in the trough on the setup. Note, any desired alkane can be prepared by this method by varying on the salt which is being used. That is what I was emphasizing in the previous slide. That we can also prepare, for example, so we can prepare any type of alkane depending on the salt. So you always check on the alkane that you want to prepare, and if it has, for example, it needs to be we want to prepare an alkane which has two carbons. So it means the salt will have three carbons, such that the two carbons will be responsible for the preparation of the alkane, and the other one will be part of sodium carbonate which is going to be formed. So we can do that by using a general formula just to generalize what should we do and which material should we add when we want to prepare a desired alkane of our own interest. So we can use this chemical formula, CnH2n. This is the general formula which you can use, Cn H2n plus 1. Instead of here to put 2 as a general formula of alkane, we are putting plus 1. Why are we putting plus 1 here? It's because this one already has a carbon here, so we don't have to put 2 here. So we're going to add 1 only. So here we are producing an alkane which is CnH2n plus 2 and sodium carbonate, where it can represent 1, 2, 3. So remember, it depends here. The product, the type of alkane that you're going to produce, that you want to produce, determines the salt which you are going to use here. As I also explained in the previous slide, I said, for example, if here we want to prepare ethane, ethane has 2 carbons. It means the salt that we're going to use here is supposed to have 3 carbons atom. So it means here it will be sodium propanoate. So apart from the preparation of alkane, now we're going to look at the physical properties of methane gas which is going to be produced. Since sometimes it's very important to know the physical property of something that you are producing. So since we are only using methane as an example, so we have to look at the chemical properties of methane. So the methane gas, it is a colorless gas. It is an odorless gas. It means does not produce any smell. It is less denser than air. It is insoluble in water but soluble in other organic solvents such as benzene. It's insoluble in water because it does not form ions as well as its nonpolar compound. Methane is highly flammable. It is highly flammable. This flammability, it enables them to be used during heating as well as cooking. It ignites easily and burns with a pale blue flame. Methane is found in gaseous state at room temperature and standard temperature and pressure. The general physical properties of alkanes. So the difference is that in the previous slide we were only targeting methane, but in this slide we are targeting the general properties of all alkanes. What should we expect from all the members of alkanes, starting from methane to decane? So first of all, we're going to look at their melting and boiling point. Alkanes have lower melting and boiling points. So this is the physical property that we can get. Alkanes have low melting and boiling points, but their melting and boiling point increases with an increase in molecular size. So let us first of all dwell in this. The melting and boiling point increases with increase in molecular size. What do we mean when we're talking about molecular size? So this means that as we are moving down the homologous series, starting from methane to decane, the first notable thing is change in number of carbon atoms. Going down there, the number of carbons are increasing. That is what it means. It means when we are saying molecular size. So what makes their melting and boiling point to increase as the molecular size increases? So as the molecular size increases, we expect that there are many electrons. As the number of atoms are increasing, there will be many electrons, so there will be more distortion of electrons, so they will create a lot of weak intermolecular forces. So going down, you create a lot of weak intermolecular forces which are known as Van der Waals forces. Hence, we expect melting and boiling point to be increasing. So because of the increase of the intermolecular forces, there is also high force of attraction. So to break the bond, you need higher energy. That's why the melting and boiling point increases as we are going down the homologous series, starting from methane to decane. So smaller alkanes are always found in gaseous state at room temperatures. So which are these smaller alkanes? We are talking about methane, ethane, as well as propane and butane. These ones are going to be found in gaseous state at room temperature because they have weak force of attraction, so they need little energy to be broken. So here is a table showing us the melting and boiling point going going down the homologous series, starting from methane up to heptane. So here we have methane, ethane. So as you can see, as we are going down here, the melting point is increasing. Remember, when you look at the negative values, the one which has big negative value, it means it's small. The one which has small negative value, it means it's big. So if you can check here, their melting point is increasing as we are moving down the homologous, as well as the boiling point is increasing. Now if we check on the physical state at room temperature, the first four, they are found in gaseous state because they have few weak intermolecular forces, so little energy is needed. While starting from 5 up to 10, they are found in liquid state because they are form strong intermolecular forces. So here it's a continuation of the table. We have octane, which is 8, nonane, and decane, and the values can tell. The melting point is still increasing, going down, while the boiling point is also increasing as we are going down, and all of them are found in liquid state at room temperatures. The second one is density. So alkanes are less denser than water. So it means when you put an alkane in water, it will always float because they have low density than water. But the density increases with increase in molecular size. That is the carbon chain. So first of all, we need to understand it properly. We are saying that the density of alkanes increases with an increase in molecular size. I've already explained what do we mean when we're talking about molecular size. We're talking about the carbon chain as we are increasing number of carbon atoms. So this is so interesting. We need to understand it properly. So let's go into bottom line of what makes the increase, what makes an increase in density as well moving down the homologous series. So if we talk about molecular size is increasing as we are moving down the homologous series, it means there will be many weak intermolecular forces. These weak intermolecular forces, first of all, will hold the particles together more strongly, and is going to reduce the volume. As well as we increase in carbon chain, we are also increasing the mass of the molecule. So increase in mass, reducing the volume, this one increases the density of a molecule. So because when the molecular size increases, the intermolecular forces also increases, which makes the particle in the molecule to be strongly held together by reducing the volume. As well as increase in size also increases the molecular mass. This one increases the density as we are moving down the homologous series. So we have a table here just to illustrate changes in density of the members of alkanes. So we have methane here. As you are going down here, you can see that now the density is increasing. There are two reasons. First of all, the increase in force of attraction makes the particles to be strongly held together by reducing the volume, as well as increase in carbon chain also increases the mass. Remember, to find the density, we divide mass by volume. So if we have bigger values for mass and small values for volume, it means now the density is going to increase. The other physical property that we can talk about is about viscosity. So what is viscosity? Viscosity refers to how free a liquid can flow, or it can also be defined as resistance of fluid to flow. So if a liquid has higher viscosity, it implies that the liquid does not flow easily. Alkanes are more viscous, but their viscosity of alkanes varies depending on the molecular weight and structure. What do we mean here? We're talking about molecular weight, which means depends on the molecular size or the carbon chain and their structure, how their structure are going to be formed. So as the molecular weight of an alkane increases, this means that as you are moving from methane to decane, its viscosity also increases. So between methane and decane, it means the one which is more viscous is decane, due to an increase of molecular weight as well as molecular size. This increases the intermolecular forces which holds the particles more closely together, reducing the freedom of the particles to move. Because large molecules experience greater intermolecular forces due to large surface area of the molecule. So what it means here is that as we are going down the homologous series, the carbon chain is increasing. As it is increasing, there are two things which are happening. The surface of the substance is also increasing, as well as the force of attraction is also increasing. So this force of attraction holds the particles more strongly, reducing the freedom of the molecules to move. That's why alkanes are more viscous. So how viscosity changes with the number of carbon atoms in alkanes. So we can look at the members of alkanes. So we have methane here, which has very low viscosity, ethane low viscosity, propane slightly higher viscosity, but starting from butane up to the last one, that is decane, we expect to have more, to have higher viscosity. The reasons are because of the surface as well as because of the molecular size or molecular weight of the alkanes. Number 4, electric conductivity. So alkanes do not conduct electricity or heat. The reason is that in either liquid state or solid state, they do not form ions, as well as they do not have delocalized electrons which can be able to carry charge from one point to another. Hence, they are non-electrolyte. Solubility. Alkanes are insoluble in water. Solubility means ability of a substance to dissolve in a solvent. So alkanes are insoluble in water and other polar solvents because they do not form partial charges, as well as they do not have the carboxyl group. A carboxyl group, that is OH, which can get attached to the charges in polar substance. But alkanes are soluble in other organic solvents such as nonpolar solvents. We have the likes of benzene, gasoline. They will be able to dissolve. So that marks the end of our physical properties. But before we end the lesson, we will have to go through some of the buzz session that I have prepared just to check the understanding on the concept that has been shared. So first question is, describe how you can prepare propane. So if I'm to go inside and explain more about this question, in an explanation, I said we can prepare any desired alkane of our own interest depending on the salt that we choose. So if here we have propane, we'll be able to know which salt we can use. Explain why the melting and boiling point of alkanes increase down the homologous series. Explain why the melting and boiling point of alkanes increases down the homologous series. Explain why density of alkanes increase down the homologous series. Explain why alkanes do not conduct electricity. State 3 physical properties of methane gas. Then question number 6, complete the equation below. Here we are supposed to put the products. So for more questions, we can ask through the WhatsApp number which is here, as well as we can visit xulendo.org. So for the references materials that I have used, I've used Excel and Succeed Chemistry Book 2, Achievers Chemistry Book 2, Target Chemistry Book 2, which you can refer it if you want to find more information about what we have discussed. So for the photos used, these are the links that have been placed here. The links you can just press and find out more about the photos that have been used. This marks the end of the lesson.